Okay, so now we're going to be talking about inverses. Now, before we talk about inverses, we're going to talk about functions. Every year, that thing comes up, right? The word function. It's a relation in which each element in A is mapped to one and only one element in B. Okay? Now, what if I just called this 1, 2, 3, and 4? Simple question. Multiple choice. Only one of them is the correct answer. What or which one of them is not a function? And why? Number 1, 2, 3, or 4. Which one is not a function and why? 4. Okay. If 4 is not a function, I need to know why. Say that again. The domain is mapped to more than one answer. Yeah? Why? What do you mean 4 is inversed? Okay. So now we're leaning towards 2. Okay. The answer is 4. Now, the way that I've always tried to explain it is, and if you had little kids, these are the kind of questions you ask when you're going to buy something. I don't care if you're at McDonald's, wherever. They look at the prices. Now, if it said, I know they don't have hot dogs at McDonald's, but work with me here. If it said, hamburger $2, hot dog $2, do kids get confused? Usually they're pretty good with that. What if it said hot dog $2, hot dog $4? Would a kid be confused with that? Okay. So that's how I always think about it. The one that a kid would get confused on is not a function. But yeah, I mean, they ask everything. Why is the sky blue? How come that building is there? Everything, right? They'd be all over that one. How come the hot dog's $2? How come the hot dog's $4, right? And they always ask questions that you do not know the answers to, right? So that would be one I couldn't answer. I don't know. It must be a typo. Man, that must be a chili dog. I don't know. You want me to ask? I'll ask for you. So let's look at this one here. Let's look at 2, because can I graph it for you? Okay, I've got 2. This is x. This is y, right? So 2 is 4. So there's 2, right? 2 is 4. And negative 2. Oh, sorry, negative 4. What are we talking about? So 2 is negative 4. Negative 4 would be down there. And negative 2 is negative 4. Right? Now, does that pass the vertical line test? Can I draw a vertical line and go through those 2 points? Remember the vertical line test we always did? Everyone's good with the vertical line test, right? Draw it. Vertical line test, if a line ever goes through twice, like say I had this, and this was my graph, that's not a function. Why? Because if I draw a vertical line, I go through the graph twice. See, this is having one x. See, here's x. It's having two different y's. Like that's like, 4 and negative 4. That's like a hot dog being $4 and negative $4. Okay, huh? Well, that's kind of weird in two reasons, right? But the B passes the vertical line test. But let's look at 4. So if I had 4, here's 4, and 4, negative 2 is down here. Right, negative 2, and this is 2. So that would be that. Do you see how those 2 points fail the vertical line test? I drew a vertical line test, right? So this one is not a function. Okay? And not to put you on the spot, Corey, but what was your definition? It was good. It was the right definition. What was it again? Yeah. So basically 1x, this is how I try to keep it straight, is 1x cannot have okay, we'll talk about that if you want, 2 or more y's. Okay, so we go back to this one. Does 1x have 2 y's in 2? No. But 2 is the best distractor. Okay, even like Tori succumbed to the other explanation, and she can switch to 2, right? And then she's sitting there going, oh, I should have known better, and she was right the entire time. So even she knew the answer and she got swayed. So 2 is an excellent distractor. Can they get you on the diploma? Can they just ask, if there's 4 of them, which one is not a function? Okay? So I do want you to remember the hot dogs or whatever. Keep that straight, okay? If x has 2 different y's, graph it. Graph it, and then the vertical line test will be your little rule, I guess, to be able to. Now, here's something that is extremely important. The domain of the inverse is going to be the range of the original. And the range of the inverse is the domain of the original function. Okay? Now, just so if you can look above, see, is half of and double, these are inverses. Is the square root of and is the square of are inverses. The next line just basically states the inverse of a function may or may not be a function. Okay? So we're trying to make no fast rules there. After you've done 10 questions and they're not a function, not a function, not a function, not a function, don't say they're always not a function. Okay? And students like to make those, and it's not a bad thing, just double check. Okay? And students coming to me all the time, feel every single rational expression has a non-permissible. I'll go, really? Try this one. Oh, okay. So not all of them, no. So you don't want to make, that's dangerous when we start making generalizations that we haven't tested fully. So the one in red, that box that's in red, those are always going to occur. And these are rules that you're going to put on your study sheet. Now you guys have to make this assumption when you make your study sheet that you will not remember any of it in 4 months. So by reading over that study sheet again, 4 months from now, you'll get it all back. But don't take for granted you will remember anything, and I want you actually to assume you will not. That is how you make a good study sheet, because not only will it be good to study off of for this first exam, it will be there when you forget everything. Okay? Now, when we talk about inverses, we are often seeing, well, it's like, let's do example 2 first. For example 1, I think example 2 is way harder. Okay, multiplied by 2. What would be the inverse? Divide by 2, right? What's square? Square root. How about take the reciprocal? Don't take the reciprocal. That's like don't do anything. Yeah, when all adults stand still. Just stand still. Yeah. Take the reciprocal. Some of this stuff's pretty deep. Might not get it till you're driving home tonight. Oh, I get it. How about divide by 3, then add 1? Multiply by 3, subtract 1. Okay. And then put a big slash to that. That is the most commonly given answer. Yeah. Subtract 1. And multiply by 3. Okay, so there's a little moral in that story maybe we should talk about. What is the inverse? If you had to define inverse, what is it? Because we kind of were getting it, weren't we? And then all of a sudden, so we didn't know what it was, truly. So if you had to define it, yes, it'll always do that. If you take an inverse and do an inverse, you always get back. Yeah. But how do you find an inverse? What is the inverse? That's all I'm looking for. I think we should have that definition right below. What's the inverse? Like, do example 1 now. What would be the inverse of putting on your shoes and then putting on your socks and putting on your shoes? What would be the inverse of that? Okay, so what did you say it was? Taking off your shoes. Do the opposite order in reverse. Like, don't put it past the diploma just to have. Consider this sentence. What would be the inverse? That's it. Like, well, you're like, what? I can't even use my calculator for this. That's not math. Okay, so your definition kind of confused me a bit. Okay, what is an inverse? Come on, let's look at this one and number 4, the last one. Yep. No. because 1 over top of putting on your socks and then I need it to work for that as well, not just numbers. Yeah, no. That's only if you want to, like I'm asking for what's the inverse, you're asking me how to get back to the beginning again. I'm saying basically, like, I don't know, probably none of you have ever tried this, but may know friends that have, that your parents ask you to do something, and just to get them mad, you do exactly the opposite. You ever known anyone like that? Like, probably not you guys. But if you really want to do the opposite of what they asked, you have to do not only the thing they asked you to do. If they gave you 5 things, you have to do those 5 things backwards in the order they gave them. Okay? So taking off your shoes is very different than where it is in the sentence. So we would call taking off your shoes would be like the operation. Okay? So not only do we want to do the opposite operation, we want to do it in the opposite order. Okay? So it is the opposite order and opposite operation. So we would call the operation the taking off your shoes and the taking off your socks, but also in the opposite order, which may help you more with the last one we did in those 4. Do you see how dividing? The opposite operation is multiplying. Adding, the opposite is subtracting. We also want to do that in the opposite order. Okay? So there's 2 things to flip there. Now let's talk about, is the inverse a function? So if you multiplied by 2, say that would be 2x. The inverse would be divide by 2. So that would be x over 2. Now if you graphed both of those, you would see they would still pass the vertical line test. Pretty hard, right? The other reason I would say yes, because I just think of every 2x, 4x, 8x, they're all straight lines, right? So just through experience, but if you're on a diploma and you're getting just one of these questions, I would probably try and come up with some sort of example, like square would be x squared. This would be the square root of x. Okay, actually, when you take square root of both sides, it's always plus or minus, and that's where you get your, it'll look like this or like that, so that's where you get a null. So the best way to actually do is just do one example of each. So I'll just tell you that one's a no and the other 2 are yeses if you were to. Okay. Now, what I actually want to do is go to page 45, and there's 2 examples there. And the question could be just given to you this simply on a diploma. They will give you A, there's the original, and they'll say, which of the following is the inverse? And they just have 4 pictures, 4 graphs. Now remember, sometimes you just have to, you're going to get maybe that one question, whoa, we didn't do one of those. So what if I gave you this question? What would you try on example 4A, what would you do to get the picture? Flip it, rotate it, how much? 90 degrees? Okay. Now, the easiest way, because sometimes rotating at 90 may work for one, but doesn't for the other. Okay? The easiest way is pick actual points. We've got, let's call this point 1, this point 2, and then this one point 3. What is point 1? What is that? Negative 3, 0. What do you think the inverse of negative 3, 0 would be? Zero, negative 3. All you do, oh yeah, sorry, negative 6, 0. So negative 6, 0 becomes 0, negative 6. When you're doing inverses of pictures, just reverse the coordinates. So that would become, so maybe you need to even write it down at first. So I've got in point 1, we've got negative 6, 0, and it is going to become 0, negative 6. Okay, so that's point 1. So negative 6, 0 becomes 0, negative 6. So this becomes what we call 1 prime. I'll put a little prime on there, and any calculus uses a lot, right? That's saying after 1 move, after 2 moves, you would put 2 ticks. That's double prime. So we know that 1 is here now. Okay? So it is very valuable to bring in colored felts, colored pencils, that sort of thing in a diploma, because you're going to be doing lots of transformations and moving on the graph. Okay, point 2 is 0, negative 6. That will become negative 6, 0. So this becomes like 2 prime, right? And point 3 is 6, 0 will become 0, 6. So the new point is up here. Therefore, my new graph will be like that. So it may look like we rotated 90, but we actually didn't. It looks like that, but because this point definitely did come up to here, but point 1 didn't go up here, did it? Right? See, the vertex went from here to here, but this point came from here, and this point, right? So it's actually not a, and you will see, then if you, again, bring in a ruler or whatever, it is always a reflection across what we call, that's the y equals x line. Okay? So we always have a reflection on y equals x. Now this may not seem so clear when your shape goes through the mirror. But now I'm going to back up to example 3 on the page before, and we're going to talk about, here's all my points. So I've got negative 4, negative 2. Okay, so let's graph negative 4, negative 2. So negative 4, negative 2 is there. And then negative 2, negative 1, right there. Negative 1, 0, 0, 1, 2, 4, and 3, 8. Okay, so it's probably a graph that goes like this. Okay. Now it says do the inverse. Now the inverse would be negative 2, negative 4. This is going to become negative 1, negative 2, 0, negative 1, 1, 0, 4, 2, and 8, 3. So negative 2, negative 4 would be here. Negative 1, negative 2 be right there. 0, 1, 0, negative 1, 1, 0, 4, 2, and 8, 3. Okay. Now this one may be easier to see how it's a reflection on y equals x. And sometimes even just turning your book a bit and looking right down the middle line, you can see the blue and the red are a reflection on the x-axis, on y equals x, sorry. And you'll get that by not actually inversing the shape, do inverses of each point. Connect the points, and then you may even have to step back and go, oh yeah, it is the inverse. Okay, yeah, that's a reflection. I see it now. So don't get caught up on trying to actually do an inverse of the entire shape. Do coordinates, then join them. Okay, so let's do this one here. Again, let's reflect just the points. So this one here, that is negative 6, 0 again. That would become 0, negative 6. We'll do that in blue. Okay? And maybe you need to put a little check mark there. So you're like, yeah, I got that one. And this one here, this is 0, 4. Right? So that's going to become 4, 0. Come on over there. So maybe this one could be this one, and then we go like that, 2 check marks for that one, right? And then the other one is negative, or 6 zeros, going to come 0, 6. So it's coming up there, and there is my, and you'll see, once again, that it will be a reflection. Anything that's on the mirror will stay on the mirror. Anything that is farthest away from the mirror will be farthest away in the reflection. Okay. Now, just for sake of time, let's go to the next lesson. I'll get it to you. Okay, Corey, you with me here? Okay, so just to sum up what we've done, to do the inverse of a function, the reverse of the coordinate, you reverse the coordinates. It is a reflection on the line y equals x. You interchange x and y and solve for y. Okay, we'll do that in a second. The domain of the inverse is the range of the original. The range of the inverse is the domain of the original, and the inverse of a function may or may not be a function. Okay? So what I want to do now is go to the next page, and let's do some inverses. Okay? Now, here is the way they will ask you to do an inverse. Now, this is very confusing, especially to anybody that's in calculus, because an inverse is given as f to the negative 1. But if I said, what is the reciprocal of x to the negative 1, it's 1 over x. See, x and 1 over x, or x to the negative 1 equals 1 over x. Those two are not inverses. Those two are reciprocals. Okay? So, when you have a variable to the negative 1, it means find the reciprocal. When you have f to the negative 1, it means find the inverse. Okay? So, it is the calculus students that will most come into this because of when they're doing reciprocal functions. And again, that is so close that it becomes very confusing. The other way to say inverse is solve. You don't see it that often, but where is it that I see that? Yeah, oh yeah, there it is. So they can also ask you to determine x equals f of y. Okay? That's another way to say inverse. Okay? Now, here's how you find the inverses of an equation. F of x equals 2x minus 3. The first thing you want to change that is to y equals 2x minus 3. I haven't really done anything mathematical here, but to find the inverse of an equation, you need to switch x and y. Well, it's pretty hard to switch x and y when there's no y. So we're going to put it in there. Then step 1 actually really is just interchange x and y. That's all I've done. Okay? So all I did was switch x and y. Now that is the inverse. The problem is, often they will want that put into the form y equals. Right? And that's helpful for you too, so you can put it in your graphing calculator to see, are they inverses? Check the pictures out. So then you're going to have to, so 1, you always, right? And then for step 2, you solve for y equals. Okay, so how am I going to do that? Well, I'm just going to do some algebra. I will add 3 to both sides. So x plus 3 equals 2y. And then I will divide by 2 on both sides. And I will get x plus 3 over 2 equals y. So then this will be my final statement. F inverse of x equals x plus 3 over 2. Okay, so take f of x, change it to y, switch x and y, solve for y, and then change to f negative 1x. Yep. Yeah, the function equals and y equals are interchangeable. Yeah, so you just have to know that. Okay, that's good stuff. Like this is a good example to have on a study sheet right here, right? F of x equals 2x minus 3, and then I would, you might even make that as a step. Number 1, change fx to y. Step 2, exchange x and y. Step 3, solve for y. Step 4, change y to f negative 1x. Okay? Okay, now let's talk about, we're going to do the next two examples. So, if I have y equals x, or f of x equals x squared minus 4, okay? Now, if we get our calculators out, okay, let's just put in x squared minus 4. Okay, now when you hit your window settings, just hit zoom 6. So we're all on the same one. Now, you can also see that if you look on the graph that they have on the page, they go by twos, right? So if I want to stay consistent to that, I'm just going to hit my window, and I'm going to change my scale to twos. And then it kind of looks like the other graph. You can see, because it's like a widescreen, do you see that the x's are spaced out more than on the y's? So you can hit zoom, which is zoom 5, which is zoom square, and it tries to remedy that. Okay, so now the x's are in the same space as the y's. So that is probably the closest I'm going to get to that, because they actually made their max as 12 and negative 12 all the way around. But now, the question is, what would the inverse of that look like? Now, first of all, just by looking at this, what is the domain of that? Domain. X in the reals. Range. Okay. So, domain. X is in the reals. Range, we're saying y is greater or equal to negative 4. Okay? So, it says determine x of f of y, which is the same thing as f negative 1x. Okay? So, my equation is y equals x squared minus 4. My first thing I need to do, switch them. X equals y squared minus 4. Now it says solve for y. So I'll add 4. Add 4. X plus 4 equals y squared. Be very careful with this step. When you take the square root, make sure you put plus or minus. So plus or minus square root of x plus 4 equals y. So f of negative 1x equals plus or minus the square root of x plus 4. Now, your calculator does not have a plus minus button that they could do, so it does take two steps. You're going to put the positive 1 in, so you go second square root x plus 4, and then the negative of the same thing, square root x plus 4. Okay. So what you want to do is just do right click, take a screenshot, black and white. Oh yeah, that's right, you guys don't have smartphones. And yours too can look this pretty. Okay, now, what is the domain of the new one? Talk to me. -4, and what is the range? Y's in the reals. What did we notice? Yeah. Domain and range, they switch. Okay, can I just go back and remind you of these? The domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. They will always trade. Okay? Now, why would that be good to know? Okay, it says Don incorrectly determined the inverse of the function. And he got, so here's the real function. Y equals square root x minus 3. And Don, he's not the smartest guy in the world, right? So he got y equals x squared plus 3 when he did the inverse. Okay? Well, let's see. Let's do it. Okay? So what's the first thing we do to find the inverse? What should I do? Great. So that'd be x equals square root y minus 3. Then what should I do? I want to get it to y equals, right? So what should I do? Square both sides, right? So x squared equals y minus 3. Then what should I do? Add 3. So I get x squared plus 3 equals y. So I get the inverse to be y equals x squared plus 3. Okay, where did we make our mistake? I added 3 to both sides to get that -3 out of that. I just got rid of my square root. Okay, let's look at our calculators because something's going wrong here. So if I clear this, and I'm just going to put in square root x minus 3, I'm going to get rid of the other ones because I don't want it to. I'll just put in this. So square root x minus 3. Okay, now, because maybe I need to look at what's going on here. Because if I'm in my diploma and this happens, it's panic sets in, right? So, okay, so if we could just draw that kind of quick, where's 3 right there? And it looks like this, right? Okay, so we got that. Does anybody kind of visualize what the reflection or inverse should look like? Where's it starting from? This one starts at 3, 0. The other one should start at 0, 3. Right? And come on, I want you to picture this mirror here. So it should sort of go like this or something, right? If I was to... Well, so Okay, again, like I'm not getting this, I'll graph the other one. Y equals x squared plus 3. I know. I figured that out already. Okay, extremely obvious. That is not the reflection. Okay, so this is what you need to do. Whenever you find the original, you must find the domain and range. What's the domain of my original? X has to be greater or equal to 3. The range? Y is greater or equal to 0. If I do the inverse, what should be my domain and range for my new one? X is greater or equal to 0, and Y is, okay, let's look. This is what my calculator was giving me, right? For x is greater than 0, is any of that blue line going to be, or that blue part of the graph, is it allowed? That is why if you actually include the domain and range, it does become true. Because you must do an inverse of the equation, but you must also keep the domain and range from the first one and change it into the range and domain. So this final thing right here, when determining the inverse of a function, domain restrictions must be included in the equation of the inverse. So that's an awesome diploma question if you want to separate your 80s from 100s, right? What did Bob do wrong? Oh, Don. What did Don do wrong? That would really screw you up, eh? Who's Bob, man? Okay. What did he do wrong? He did all of his math correct, but he did not include domain and range and changed it. So you must always inverse your domain and range when you're doing these questions. And then you will get the actual inverses. Okay, the next example we don't really have to go through. If you take the inverse and multiply by itself, you should always just get x. Okay, that's what you guys were kind of, you say you undo what you did. Okay, so when you multiply something by its inverse, it should always equal x. Okay, that's all this says, this entire statement. If f and g are inverses, if you put them inside each other, if you put g of x and f of x, it turns out to be. Okay, so on, I guess finding it kind of cold in here. I've actually never noticed that before. Today it's a little chilly. I hope so. That's good for the greenhouse effect if I'm using air conditioning when it's minus 28 outside. So we'll do 1 to 11. Just do your A, C, E, ... for each question. That's on the last homework. So I'm just going to scroll through it here. And now we're actually finished Unit 1. Okay, and then the next assignment, which is the same assignment, is 1 to 8. And 10 to 13. Just do ACEG. So there's two ways I could have done that one, right? I could have said 1 to 14, omit 9 and 14, right? So I can say my domain very different ways. Or I could say do 1 to 13, omit 9. Mm-hmm. What? What's back?